Hello everyone, welcome to the AI portal, your gateway to the world of artificial intelligence. In this series of videos, we will test and explore various large multimodal models. The discussion until now has always been LLMs, but I think now we have entered the era of LMMs. What is an LLM and what is an LMM? An LLM is a model that takes text as input and gives text as the output. Whereas a LMM, a large multimodal model, is a large model that can understand and process multiple modes of data such as image, text, audio, and video. For example, you can consider the model of GPT-4. GPT-4 can understand images and videos and it can produce text as the output. So it can be classified as an LMM. So that GPT-4 is the point of discussion today. GPT-4 with Vision was announced in September 2023. It basically means that vision capabilities have been added to the GPT-4 series models. For example, there is GPT-4 Turbo, which was only an LLM and now it has turned into an LMM because vision capabilities have been added to it. It now accepts image and video inputs along with text and helps users to understand them. It can be used for various applications such as image understanding, content creation, extracting text from images, converting UI wireframes into code, etc. So this capability has also been added to the recently released Omni version of GPT-4. So, one important thing to note here is that the GPT-4 models only understand and interpret the visual content, but they do not generate any images or videos. For that, you need to use other models like DALL-E 2 or Sora for video creation. So, as GPT-4 is a closed model, not much information about the training and architecture are available. Like other OpenAI models, GPT-4 has also undergone rigorous red teaming to curb inappropriate or biased output. Despite these efforts, it is not recommended for more serious applications like medicine and healthcare in general without proper human supervision. You can read more about the GPT-4 and the system card and the kind of red teaming that has been done here in this paper. In this video today, we will mainly explore and test four important areas and assess the quality of the output of GPT-4 Omni, especially in regards to the vision capabilities. So we are doing it through code, even though these capabilities are available through GPT-4, are available through ChatGPT for free. I'm doing this because I've observed that we reach the limits quite quickly just after 2 or 3 queries sometimes when we are on the free version. So I didn't want any interruptions in our testing, so I have chosen to use the API route. So let's get started with our test. So I'm doing this in a Google Colab where I have copied the code from the official website of OpenAI and I've customized it a little bit for testing our use cases. So let's get started. Initially, we install the OpenAI package, Python package, and also we import certain libraries that are needed. And the most important thing is to obtain a key from the OpenAI website and store it as a secret in the Google Colab. You can find the secrets here on this key. If you click on this key icon on Google Colab, and you can store your OpenAI key here so that it's a secret and it's stored safely. Now, after obtaining the API key, we initiate a client, the OpenAI client, so that we can call the API. And here there are some helper methods that are used to make the process of calling this API more streamlined. The first method is convert the image to base 64. So since we want to give image inputs to the GPT-4o, we need to either convert it to base 64 and then upload it, or we need to provide a URL. Here I've taken the route of converting it to base 64 and then uploading the base 64 version of the image to the API. So this method converts all the images that we are going to use to base 64, and this method, it actually calls the API by providing whatever inputs that we have given. So let's go through this method in more detail. So what we are doing here is we take the path of the image, which is just the name of the image in this case, because I have uploaded all my files here just for ease of use, and so that you can see that what files are being tested and where they are being stored, and also the task description, which we will see later. So the prompt is structured like this. There is a system level role where you give a basic general instruction to the API. Here you say you are a helpful assistant that helps process or interpret the given image. So that is the general instruction to the API. But since you are the user, I mean in this case I am the user, there is again a user generated task that needs to be done. So the description of that task comes here, and as part of the user's request, we add that task description, and also we upload the base 64 version of the image, and then we return the choice. And then we return the content that has been generated by the API. So let's see how these images and how these prompts work in action. So the first use case that we are going to test today is image understanding. So we want to see how well the GPT-4o model understands what exactly is there in an image. Here I have uploaded an image of the place Santorini, which is basically a Greek island and a very famous tourist spot. Let's see what the model has to say about this image. So I am running this, and you can see the image here in Collab, and this is just the image of Santorini with some like flowers and all. And then we use this method to send the image the path, and we also tell it what exactly we are expecting from it. So I am just asking it to describe the image in detail. So you can see, let's read out the description that the model has generated. The image depicts a picturesque scene of a whitewashed building adorned with vibrant flowers, likely in a Mediterranean or Greek island setting, which is true. That is what we've given. And it also goes on to explain further about all the details. You can see that the building features a bright blue door and window frames, which are characteristic of traditional Greek architecture. And it also describes the flowers again on the doorway and window again in more detail. So I think we can safely say that the model understood the image in a great detail. So now what we do, since like we are happy with this description, we will just add a lot of noise to this image and see if the model will be able to like filter out that noise, and then again give you a very accurate description. So that's our next use case, which is a noisy image understanding. So if you can see, this is a noisy image, and as humans it is easier for us to understand or see the details of in an image even if there's noise. But let's see if a model can do it. So again, I'm asking it to describe the image in detail. That is the same instruction, and let's see what description is. Yeah, so if you see, again actually this time the description is even in more detail. And the image let's read the first part of it. The image depicts a picturesque scene of a white building adorned with vibrant flowers. The building has a traditional architectural style characterized by white walls and blue accents, typical of Mediterranean or Greek island aesthetics. So that's again true, and it also goes on to describe the flowers and the windows and doors in an even more detailed manner. So I think we could say that this noisy image was also very well understood by the model. So why are we doing this? Like, what exactly does this signify if a model can understand an image well? One crucial application area where image understanding is can help a lot is with visually impaired and blind users. Let's say a person who cannot see is, will be able to use this in order to understand the world around them. So that would be of great help to them if the descriptions are accurate. Actually, there is a company that called Be My Eyes, which collaborates with OpenAI, which does exactly this thing. So that image understanding is helpful in a lot of areas, but this is one area where it can be like really crucial. So yeah, so this is again like a very typical image. I mean, it doesn't have many people or too many objects. It's only basically more or less a scenery, but the model still does a good job of understanding it. Next comes another very interesting application of handwriting recognition. And so if you remember, like when we all were in school, we always used to write written notes, and writing. And there's also a theory that writing with your hand helps you to retain the information more accurately or for a longer time. So writing with hand is like always a good thing. But the thing is, when you write it on paper, you might lose the paper, or you might not find the paper suddenly. So in all these scenarios, it would be very good to have like a digitized version of all your notes, of all your handwritten notes. So that's what I am trying to test here, is whether the model will be able to extract the text from an image with my handwriting. So here I took a couple of images of my own handwriting. One of them is in German because I wanted to test how the model will be able to handle multilingual text, and the other is from a math assignment. So let's first see how it works with the German. So this will show you the image, and this is all just these are just like part of a vocabulary training where I'm trying to learn a few words in German, and I have written them down. And let's see if the model will be able to extract the text out of this image. Now, from my point of view, this handwriting is not very clear, but let's see what the model thinks. Yeah, so if you see, I mean, if you understand German, I think you can see that it's actually quite accurate. It just prints out the exact text I've written, even though my handwriting is like cursive and not very clear. So yeah, so it's exactly this, and it has also retained the way I've written it. I've written it as a list, and that's exactly extracted. And the next part is, let's see how it fares with the math handwriting. So this is an image of one of my math assignments, and again from my point of view it's not very clear. So let's see. So again, the instruction here I'm giving to the API is that to extract the text in a given image. Yeah, you can see that this API call is taking quite some time. That is because this involves images, because image processing takes more time than usual text processing. Yeah, so we finally have the result here. So yes, I mean, we've seen this is all the math terms here are like they're not exactly being printed, but you can see that it's more or less very accurate, and it really did extract the text for me, which yeah, which is quite good, because this is something very obvious for a human to do, but for a model to achieve this is significant, I believe. So this handwriting recognition, um, it can be very helpful in scenarios such as for students to digitize their notes from their class notes, like we've discussed. One other place would be organizations can really find it useful to digitize their contracts and legacy documents, which were on paper, and now they can just digitize them and safeguard them. So this is one other use case that we have tested here. The next one is image captioning. Here we upload an image of a group of people who are more or less like having a group reading session, and we ask the model to generate a couple of suitable captions. So let's see how that works. Yeah, so if you can see here, I'm giving it the image, and then I'm asking it to generate 2 or 3 suitable captions. And the model sees it as a musical session of friends, but I think I interpret, or more or less I thought of it as a group reading. So maybe you can tell me in the comments how you perceive this image. Do you think these captions are apt? Or do you think it's a reading session, or do you think it's kind of like a musical grouping? Yeah, but more or less the captions, if from seen from the model's point of view, they seem to be really working quite well, because these are good captions like harmony at home, living room concert, or yeah. So that is one more use case, and the next one is the wireframe code generation. So this is exactly not a wireframe, but it is the screenshot of a website that I often use, which is the tomato timer. This is basically it's the Pomodoro technique, which like when you start it, it starts a timer. You work for 25 minutes, and then you stop for 5 minutes, and then you start for 25 minutes. So this is more of like a productivity tool, which I took a screenshot of, and I what I want it is the model to generate code in HTML, CSS, and JavaScript to develop the web page shown in the given image. So I'm just asking it to replicate it, but you can also upload wireframes which you've made, and then see how it works. And then I've already run this in order to save time, and it did generate 3 files for me, which are index.html, styles.css, and there's also the JS script file, which is script.js. So what I have done is it has generated the code in 3 sections, and I've put them in 3 different files: a HTML, CSS, and a JS file. And now I would like to see how it looks. I mean, whether the code works or not. Let's open Just a second, give me some time. Yeah, so I've already added this just to save time of the copy paste. And you can see that, I've copied the index.html here, and likewise the script is in here and the styles it's here. So I'm not making like any changes to the code. It's entirely the code that the model gave me, and I'm just copy pasting it and I'm running it without debugging. And let's see how it looks. Yeah, so this is the output of the model's code. So this is not my code, this is entirely the model's code. I would say that it's very accurate. If you can see the image, you can also see the web page here. If you see, yeah, this is the original web page, and this is the web page that was generated by the code from GPT-4o. So if you see it, like it has really followed my instructions, and the page looks like very similar. And now let's see if it's working. I'll say start. Yeah, it works. And so when I say start, it starts the timer, and when I say stop, it stops, and then you can reset it. So it's also a working version. It's not just that it looks the same, it also works the same. So what, it's like just in less than a minute I have a code for like whichever website I wanted to replicate. So you can see that this wireframe code generation has also worked quite well. But you could also argue that this is like a very simple example, and this use case has been tested like many times. But yeah, so since like I wanted to show a demo in a video, so that's why I've chosen a very simple example. Maybe you could try it out. You could try out complicated examples and ask the model to generate code and let me know your experiences. So that is the wireframe code generation. And the last one we are going to discuss is the video understanding. So there are many models, and there are many efforts that have been done to build image generation models and image understanding models. But for video, the progress is still slow. We are just getting started with video. So I wanted to see how well video is understood. So for this, I've like copy pasted like codes differently from the OpenAI cookbook. So in the OpenAI cookbook, you have a boilerplate code to like get started with video understanding using GPT-4. So I've uploaded a video, which is this word representations.mp4. This basically has code. It shows a Jupyter notebook, which has code to convert text to numeric representations using bag of words and TF-IDF and methods like that. So this is that video. It's a very short video, and let's see how it works. So the thing is, each snapshot in the video is treated as a frame, and here we are counting how many frames are basically there in this video, and then we are converting that to base 64, just like how we converted the images. So there are on the whole 527 frames read, and because just for like to save some time, uh, let's um, let's only process the first 50 frames and see if the model is able to understand what exactly is there in the video. So this is like just one of the first frame. If you can see, I'm like importing the count vectorizer, and I'm just trying to fit it and get a bag of words text to numeric representation. So in the prompt messages, all I'm asking is For the model to give a detailed description of the video. That is all I'm asking. And I've set a max tokens here. And if you see, if we can execute this and see, so here if you see, we are only sending the first 50 frames and we are asking the model to like understand it. So it's kind of like a video is processed as a sequence of frames or images. So continuous images, not just any random images. So there are, each frame is treated as an image and a continuation of these frames is the video. So let's see how the model understands this. So if you see, let's read it. This video is a tutorial demonstrating how to perform text vectorization using the words model in a Jupyter notebook hosted on Google Colab. So that's quite accurate. The video walkthrough includes importing necessary libraries, defining a corpus, and fitting the count vectorizer model. So which is all correct. And again, there is a more detailed explanation of how that's being done, and it's also explaining the code in the video. So which is great, and it's quite detailed in my opinion. So yeah, that's how we see the the understanding of this video. So it also gives us a conclusion, like throughout the video each step is clearly shown with code cells and output of each code execution is displayed, and yeah, making it a helpful resource for understanding text vectorization in natural language processing using Python. So yeah, this is again another example that it can really understand video as well. Though you can see that it's slow, but I think it would the speed would definitely improve with time. Of course, I mean, so the all the images and the video I've chosen here are something that are completely unseen by the model before, because they were only my images which I haven't really uploaded anywhere. So in spite of that, the performance of this model is quite superior, especially with the handwriting part, because there I was expecting some discrepancies, but the model did surprise me. So these are my experiences with GPT-4o. What were yours? Let me know in the comments below. And in the upcoming videos, we will see how some of the other open source multimodal models like Llava work with respect to the same use cases. We will use the same tests and compare the responses. So stay tuned. Thank you for watching.